Okay, people, let's begin our class for today. Welcome to your math class 7B. Topic for today, our topic for today is economics application for linear equations. The objective to strengthen the knowledge about how apply the economic linear equations. Okay, we go to the chat in this moment. We are with us. Atakia, hello, how are you? Sami Camargo. Julito, how are you? Samuel Bernal, hello, how are you? Mariana Noah, hello. Thank you that you are here with us. Thank you, thank you. Today we have some rules for our live class, okay? Please, I need that everybody pay attention to these rules, okay? First one, the chat, always our chat must be used exclusively to send teacher questions, send answers, and give comments in front of our class. Okay? So please, it's necessary that everybody, please pay attention. The second, please, you are the responsibility use of the design will allow a quiet class and will evidence personal great behaviors. Okay? Why I'm saying that? Because you're writing a lot of things in our chat, and you know how's YouTube and that the video will be a lot, okay, in YouTube. So it's necessary that everybody take account which what we're saying, okay, and we're typing into the box. Okay, so please be quiet with that. This is the first question there. The point is if any students leave evidence of inappropriate comments, they may they may be expelled from the room by the YouTube administrator. You know, like YouTube always ban it to these people that are saying bad words or they are speaking things about some other aspects. Okay, or if you put uh, a word a lot of times, okay, and will be subject to, and I'm going to put you on videos on the observer, okay. It's so important that you know because there's some people that are speaking a lot of things that are not relation with the class and have no relation with the activity. So please, everybody, we are in class and we have to put attention. Okay. Now remember, the video is allowed to YouTube in order to be again considered by the students in case of understanding a specific procedure. This is really an academic material. Okay. So everybody, please I'm going to put again the slide about the topic and objective for today. The topic economic applications for linear equations. The objective to strengthen the knowledge about how apply the economic with linear equations. So please everybody copy in your notebooks and your notebooks the topic and the objective for today, and let's begin our beautiful class. Okay, please remember, uh, everybody, be quiet with the things that you are typing on the box, on the chat box, okay? Because you can be banned. And if you put some bad words, I going to uh, put the observation in our book and furious, okay? And remember that like this video, it's a lot, and you have the evidence. I have the evidence that you was speaking bad words. Okay, saying no more, let's begin with our beautiful class for today. Okay, please, we're going to watch this beautiful video. Okay, we want to watch this beautiful video with the linear diamond equations. Okay, it's only a structure about how we can use the um, the diamond and the supplies. How can you use it using the linear equation? So everybody, let's pay attention to this video. Okay.
Here we go. One step at a time, don't be living on the line.
In this lesson, I'm going to illustrate and explain how to derive a demand equation using data from a demand schedule or a demand curve. You'll recall from earlier lessons on demand that I used the example of a survey that I gave to my class to determine the demand for candy in a week at a range of prices from $2.50 down to 50 cents. And this is roughly what we came up with. Of course, the actual data wasn't a perfectly linear relationship like we see here, but I'm changing the numbers slightly to demonstrate how we can derive an equation to represent the demand for a good when that relationship is linear. Notice, of course, that the law of demand is clearly on display here. At lower prices, there is a higher quantity of candy demanded by my students, and at higher prices, there is a lower quantity demanded by my students. What I want to talk about now is how to come up with an equation to represent demand. And you may be thinking right away, well, I learned in middle school or high school that the equation for a straight line is always represented by y equals mx plus b, or some version of that equation. In this typical linear equation formula, we had a couple variables like m, which represented the slope, and b, which represented the y-intercept. Well, we're going to kind of flip this equation on its head today because this does not work for demand. The reason is that in the y equals mx plus b equation, y is the dependent variable. In other words, the value on the vertical axis depends on the value on the horizontal axis. But recall from our definition of demand that in fact quantity demanded is the dependent variable when it comes to demand. The quantity demanded of a good depends on the price. The price does not depend on the quantity demanded. So what we're going to be doing is kind of flipping the script here, and instead of y being the dependent variable, we will be talking about the quantity as the dependent variable. And the equation we're going to use to represent the demand for a good can be expressed as follows. Q equals A plus B times the price. P is on the vertical axis, so basically we are taking what would normally be the dependent variable, the value on the vertical axis, and making that our independent variable. So in this case, Q depends, so this is dependent, on price, which is independent. We've got a couple other values in here as well, whereas the B variable in our y equals mx plus b is the y-intercept. In our demand equation, the A variable is our Q-intercept, or the X-intercept. This is the quantity demanded when the price is 0. So we can say the quantity demanded when price equals 0. Sometimes this is known as the autonomous demand. It's independent of the price. If the price were 0, how much candy would be demanded? In other words, if candy were free, how much would my students have demanded? We're going to show how to calculate this in just a minute. Our B variable is not, as you may be thinking, the slope. Rather, it is the inverse of the slope. Why is that? Well, because we are now measuring the change in quantity resulting from a particular change in price. So whereas the slope would be change in y over change in x, we have flipped that around because our x variable is q and our y variable is p. So this is the traditional way you may have learned the m variable in your linear equation, but we are now talking about the b variable in our demand equation. So we have here the basic equation for demand for a good. The quantity demanded of any good can be represented by the equation Q equals A plus B P. What I need to show you now is how to actually determine the A and the B variables using data from a demand schedule or a demand curve. All right, so let's get down to business now. We know that the B variable is the change in quantity resulting from a particular change in price. It's pretty easy to find that because all we need is two quantities and two prices from our demand schedule. And we can do Q2 minus Q1 and divide that by P2 minus P1. Let's choose a couple price and quantity combinations from our table. Let's choose 400 as our Q1 and 300 as our Q2, and we'll choose $1 as our P1 and $1.50 as our P2. With these, we can plug the numbers in and calculate the B variable. So we can do 300 minus 400 divided by $1.50 minus $1, and that can be simplified as minus 100 divided by 0.5. Let's do that calculation now. We can do 100. We'll make that negative. Divided by 0.5 gives us a B variable of negative 200. So we can now plug that in actually to our equation here. QD, quantity, equals A plus negative 200 times B. There's an important point to make here, and that is that the B variable will always be negative because there will always be an inverse relationship between a good's price and its quantity demanded. So whenever you plug in two quantities and two prices, you're always going to end up with a negative value for the B variable. This should say P here, not B. Now, how do we find the A variable? We define the A variable as the Q-intercept of demand. It would be the quantity demanded at a price of 0, but we don't have a price of 0 here. Our price only goes down to 0.5. But what we do have is everything in our equation except the A variable. So all I need to do now to find the A variable is to plug in a Q and a P from my schedule to the equation that we already have. So let's do that. Let's just choose this combination here. I'll choose a price of 2 and a quantity of 200. So I know that when the quantity is 200, I can say 200, that's Q, equals A, and I'm going to now just cancel out the plus sign here, and we'll say minus 200 times the price of 2. So I've just chosen this point on my demand schedule, which would represent this point on my demand curve, and I can solve for A by completing the equation here. So let's do that. So move down a little bit. I know that 200 equals A minus 200 times 2, which is 400. To solve for A, I move the 400 over here, and I get 600 equals A. There's my A variable. And that would have been pretty easy to determine actually, because I can see right here that if I were to continue this demand curve down to a price of 0, the quantity demanded is 600. Okay, so we now have our complete demand equation for candy based on the demand schedule and demand curve we see here. We know that the quantity demanded equals 600, that's the autonomous demand, the quantity that would be demanded if candy were free, minus 200. That's the inverse of the slope. That's the run over the rise. That tells you by how much quantity will increase for every $1 decrease in price times the price. So let's talk about that B variable one more time. If we started at a price of $2 right here, and the price fell by $1, how much does the quantity demanded increase by? It's pretty obvious. We know it's 200 because there's a negative 200 B variable. So we have the rise and the run, and the B variable equals the run over the rise. This is why we say it's the inverse of slope. You learned in grade 8 or 9 that the slope is rise over run, but the B variable in our demand equation is the inverse of slope. That's the run over the rise. So that, ladies and gentlemen, is how you determine the equation for a linear demand curve. You first find the B variable. Let's go through the steps here. So how to find demand equation. The steps that I recommend: 1. Find B variable. Choose any two quantities and prices and find the change in quantity divided by the change in price from your demand schedule. 2. You find the A variable. And to do that, you choose any point on the demand curve and solve for A. Once you've done these two things, you will have your demand equation. In future lessons, we'll talk about the factors that can cause a change in the A variable or a change in the B variable and how that will affect the shape.
Okay, people. Okay, my little and awesome students. Look at that. How the linear demand equations. We are using linear equations. This is a table of functions. Okay, there's no different about we are speaking about. Look at that. The axes are changed with price. Price. Okay, but now it's no y-axis. It's price. And now we don't speak about x-axis. We are speaking about quantities. Okay, but look at that. We have the equation. Okay, and if we have the equation, look at that. It's the same equation. Y it's equal mx plus b. The dependent, slope, and the intercept. This graph and these numbers only represent now the quantity of the price of the product. Okay, very good. So in this case, we only are changing the value. Quantity is equal A plus B and P. This P is price and quantities. Okay, excellent, very good. Now look at that. This A is the intercept, or is the same equations. Okay, now we're speaking about the slope. Okay, changing y is changing x. The only thing that we have to interpret it in other respect. Okay, but it's no difficult. Okay, this is our video that we begin today for to use the topic of linear of equations. Okay, in this case only the one equations. Okay, now let's check this web page where we can find some very important aspects about the systems of linear equations in two variables. Look at that. We're speaking here. Look at that. We have in this case a negative slope. Look at that. We have a negative slope. In this case, we have, look at that, two variables. We must to reorganize the equation in y terms to know if the slope is positive or negative. But we are graphing these equations in this type. Yes, this is the economic form that we can see how we can work with the linear demand. Okay, but in this case we can check it using the solving of system of linear equation graphic form. Okay, now look at that. We have this equation: 2x minus y it's equal 1, and minus x plus 2y it's equal 7. Okay, look at how we can graph it. Okay, very good. We can graph it here. Look at that. We have the graph of 2x minus y equal 1, and the graph of minus x plus 2y equals 7. We are finding this intercept, this point of 3.5. It's how we are trying to understand how can we find it using the substitution method in this case. Okay, I'm going to read some very important comments that you are doing now. Okay, Sami Cepeda said, teacher, I don't understand. Don't worry, in this case we are changing the y-intercept, okay, the y-axis for price, okay, in the economic topic, okay, and x for quantities. This case, this solution, this intercept point, that's when we were speaking about the intercept point, okay, the equilibrium economic point. Okay, don't worry. Now Mateo say, I don't understand the question. Don't worry, only we are changing the variables. Now we're going to change y for price and x for quantities. Okay, but don't worry. Sami Cepeda, very good. This is how we are speaking. Okay, Mateo say that y equal mx plus b. Very good, excellent. Or is the movie of demand for the price of product. Very, very good, Samuel Borda. Excellent that interpretation. Excellent, very good. Now let's continue. Look at that. And when we are graphing these equations, okay, we are trying to find the intercept. But look at that. We have a lot of things to do if we want to graph it. Okay, it's really difficult. Okay, but the speaker is longer, but we can do the substitution method in this case. Okay, something to remember of our last class. Remember, if we have two linear equations, okay, we have one intersection. So in this case, we have only one solution. Okay, in some cases, we can check that we have parallel lines. In this case, we have no intersections and no solutions. Okay, no intersections and no solutions. And we can check and we can find lines coincident with infinitely many solutions because one graph coincides with the other one. So we have infinite many solutions because one is over one. Okay? So remember, one intersection, one solutions. Parallel lines, and when lines coincide. Okay? Now, we have to use the substitution method, okay, to solve this equation. I'm going to explain it how we can do this expression. Okay, so everybody please pay attention. We're going to use the substitution method. It's longer, but it's not difficult. Look at that. First, I'm going to take one of these two equations, okay, and I'm going to put it in y terms. I'm going to take 2x with a pen. Okay, I'm going to take 2x minus y, it's equal 1. Okay, now remember that I have to put it in y terms. So in y terms, it's in this case minus y. Okay, it's equal 1. I'm going to move these two to the right side. Okay, very good. Remember, we have to change the sign, minus 2x. Okay, but look at that. Y is negative. In this case, I'm going to multiply the equation by the number minus 1 to change all the signs. Okay, so we have in this case y, it's equal 2x positive, okay, because we changed the sign, minus 1. Okay, now look at that. I have y, it's equal to 2x. Remember, this is that 2. 2x minus 1. Okay, but now I have, remember that we are speaking about substitution. I'm going to put this answer into the other equation. Okay, in this case, the other equation is minus x plus 2y, it's equal 7. Okay, now remember, I have to take this into this y. Okay, now minus x plus 2 parentheses 2x minus 1 equal 7. Okay, very good. Now I'm going to multiply 2 times 2x and 2 times minus 1. Remember the signs. Minus x plus 2 times 2x, 4x. Okay, very good. 2 times minus 1 minus 2 equal 7. Okay, let's continue. Now look at that, we have like terms. So look at that, minus x and 4x are like terms. I'm going to move these two to the other side because 2 and 7 are like terms. Okay, minus x plus 5x, 4x, excuse me, 3x equal 7 plus 2. Okay, 3x, it's equal 9. Okay, now, oh, thank you. The 7, remember, Mateo, in this case, 7 is because we are using this equation, the second equation. Okay, now I'm going to move this x. X, it's equal 9. This is a 9 over 3. So x, it's equal 9 over 3. 3. Look at that. We have the x is 3. Very good. Now I'm going to put this 3 into all both equation on only one. Okay, I'm going to put in the first one. Look at that. I'm going to write again 2x minus y, it's equal 1. Okay, now remember, x is equal 3, so I'm going to take 2 times 3, okay, minus y, it's equal 1. 2 times 3 is 6, minus y, it's equal 1. Okay, now I'm going to move this 6 to the right side, okay, because 6 and 1 are like terms. Okay, and remember, we have to put all in y terms. Y minus y, it's equal 1 minus 6. So minus y, it's equal minus 5. Now I'm going to change the sign, multiplying all the equation by minus 1. Okay, so the answer in this case is y, it's equal 5. Look at that. We have now that x, the answer is x3 and y, it's 5. And look at that. Yes, we have the answer 3 and 5. 3 and 5. Very good. Excellent. Please remember that this video will be uploaded to YouTube in 20 minutes. Okay? And in these 20 minutes, if you want to check again what happened, if you are trying to, or you don't understand, or to say what happened here, you can go again to the last video, to this video, and say, okay, in this part I don't understand. Okay, what happened here? Okay, the teacher is multiplying, or the teacher is dividing, or the teacher is watching us the intercept point. Look at that we use the intercept method. In this case, this is the substitution method, and we find the intercept 3 and 5. Now I'm going to read some comments that you have here. Okay, say, teacher, if the demand is 20,000 products and the price is $2, okay, we have to wrap it first, okay, or to know, Sammy, Borda, if we have to move the supplies or the demand equation, okay. Morante, we're going to use decimals? No, today we're going to use Quizlet, okay. Sammy Chodo, okay. Samuel Camargo 3. Where is the 7? Okay, very good. The second equation, excellent, Samuel Camargo. Mateo, don't worry, Mateo. Remember that we are taking the two equations and we are putting the first one or the second one in y terms. And later we have to replace this equation into the y and the other equation and only calculate the answer. In this case, look at the process. X is equal 3. Very good. Julian, 3. Okay. Now we have to replace 4, find y. Very good. Teacher, where's the 5? Okay, remember that x takes the 3 value. Okay, so it's 2 times 3, 6. Now 6 to the right side to like term. Remember that we have to move the like terms. In this case, minus y is equal 1 minus 6 minus y it's equal minus 5, and I take the value minus 1 to change the signs, and y it's equal 5. In this case, for this reason, it's 5. Very good. There's Sammy, 6 minus 1. Very good. Some of the question of Mateo. Very good equation. The 3, the 3. Okay, this number 3 is because the process have here, Burgos. Look at that. Minus x plus 2 times 2x, 4x. 2 times minus 1 minus 2 equals 7. Okay? 3x is equal 7 plus 2, 9. 9 divide 3, 9 over 3 is 3. Look at that. For this reason, is 3. Okay? Gabby, don't worry. We must continue with this class, okay? But remember that you can go to the video again, and in this form you can review this topic, okay? Don't worry, we have to continue, okay? Please, everybody. Now, solamente tenemos 2 minutos en la sección 5 minutos para persona. 2 minutos solamente tenemos. Observen. Una persona desea ingresar al cine y comprar crispetas. La boleta cuesta $10,25 y las crispetas cuestan $4,35. Además compró un refresco con un costo de $2. La cantidad de dólares gastados por esta persona es... Listo, chicos, las respuestas rápido en nuestro chat, por favor. ¿Listo? Por favor, recuerden que es la única parte en español. Así que, por favor, rápido. ¿Cuál es la respuesta? ¿Cuál es la respuesta en este caso? ¿Ok? Estoy esperando sus respuestas. La boleta cuesta $10,25. Las crispetas cuestan $4,35. ¿Ok? Además, compro un refresco de $2. ¿Cuánto está costando todo? ¿Ok? Rápido, mis chicos. ¿Cuáles creen que sean? ¿Listo? Mientras tanto nos dice aquí Mateo que cuál es el link del video del señor de la ecuación. Recuerden que pueden ingresar a mi planeación y ahí pueden encontrar los respectivos videos y las respectivas ecuaciones. Ok, chicos, ¿qué respuesta tenemos? ¿Qué respuesta tenemos? Rápidamente, ¿cuál es la respuesta? Ok. D, 16,6. La respuesta efectiva es 16,C. Respuesta D. Perfecto, excelente. Muy bien para cada una de ustedes. Ahora, rápido, chicos. Tenemos nuestra siguiente actividad, y con ella finalizamos nuestra clase. Tenemos exactamente los 10 minutos para realizarlo, así que de esta manera vamos a jugar individualmente, ¿ok? ¿Ok? Muy bien. Por favor, todos entren con su nombre real. Please go to www.quizlet.live and please put the code. I need that you use your real name, okay? Very, very good. You can use your real name. It's necessary that you put your real name to do the activity, okay? Please, everybody, please. Mateo, the correct answer is D. So, everybody, please use your real name to do our beautiful game using Quizlet. Please, everybody, I'm waiting for your users. Please use your real name. Come on, everybody, go, go, go. Very good, Juanjo. Excellent, Sami Cepeda. Hello, Alejandra Galvis. How are you? Fine that you're there. Excellent, very good. Very good, Hannah So. Very, very good that you're there. Sami Cepeda, excellent. Santiago Sanchez, excellent. Samu Morantes, hello, how are you? Julian Andres, very good. Ana Sofia Hoyos, hello. Samuel Felipe, excellent. That you're here in our beautiful class. Santiago Sanchez, excellent. Maria Castro, very, very, very good. No, Mateo, it's D, no B. D. D. Of diamond, okay? Very good, 14, excellent. Samuel Andres, very good. Samuel David, excellent that you're there. Please, everybody, run, 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 run. Julian Andres, hello, how are you? Mariana, hello, how are you? Mateo, hello, that you're here in our beautiful, beautiful Quizlet. Okay, very good. Vale Vargas, hello, hello, Vale, how are you? Excellent. For 20, please, everybody, we need 3 more. Okay. Okay, don't worry, Arcesito, that I know that you are there. Okay. Okay, 18, we need 2 more. Okay, Juanjo, Julio, Alejandro, Samuel, Samuel Cepeda, Mariana, Samu, Samuel Bernal, Ana Sofi, Samu, Andrés, Santi, Sara, Samuel, David, Mariana, Julian Andrés, Mateo, Mariana Paula. Okay, very good. Okay, no more? No more in this moment? Okay, very good. What happened? Mariana Nova said, Jose, don't worry. No, Sammy Arce, say it like that. Don't worry. Please remember, Novita, that you have go to Quizlet.live. Quizlet.live. Okay. In this form, you can play. Okay. www.live. Quizlet.live. 19 players. Okay. Julio Samuel Burgos, very good that you're there. Excellent, excellent. Very, 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 very good. Is how great? Yes, why no? Why? Yes, really, Novita? It's because you don't have a credit code? No, I can't believe it. Okay, don't worry, Novita, don't worry. For the next game, you can play, okay? Because we need to begin now in this moment. We have to begin, okay? Very good, with 20 players. Okay, we have to begin. Sorry, I'm going to. Okay, let's activate the music. Okay, let's play the game. Very, 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 very good. Okay, let's begin. We have 7 minutes more. Okay, let's continue. Very good, chameleons. Ostrich, very, very good. You are fine, excellent. Very good. Snakes, what happened? Reindeers. Penguins, very good. Estrellas, very good. Chameleons, let's go. Come on. Boom at one. Very good. Rangers, very good. Excellent. What happened, alligators? You have a mistake? Okay. Very good. Oh, sorry, chameleon. 0. Okay. Very good. Let's go. You can do it. You can do it. Okay, foxes. Sorry, foxes. Bye. Sea dragons, excellent. Penguins, come on, red sea dragons. Penguins, come on. Rinders, come on. Arches, come on. Puffins, sorry, puffins. Pandas, oh, come on, pandas, you can do it. Let's go. Chameleons, again, come on, you can do it. Yes, very good. Let's continue. Oh, sorry, chameleons. Bye. Sea dragons, come on. Oh, that was so interesting. This is so interesting in this moment. Come on, people, we have only 6 minutes more. So, come on. Very good. Sea dragons, excellent. Pandas, oh, come on, pandas. You are doing so fine. Very good. Very good. 8, very good. Jamaican, what happened with the 4 answer? Always you jump in the 4 answers. Sea dragon, excellent. Pandas, excellent. Very good. Let's continue. Sea dragons and pandas. Oh, come on. This is so interesting. Siberian tigers, come on. Alligators, you're there with koalas, with tigers. Very good, koalas. Come on, snake, you can do it. 8 and 8, sea dragons with pandas. Excellent. Foxes, very good. Oh, sea dragons, you are the lead in this moment. Excellent, very good. Koalas, come on, you can do it, koalas. Puffins, you are there. Come on, foxes. Oh, sorry, foxes, bye. Chameleons, come on, alligators. Alligators with sea dragons. Come on, sea dragon. Oh, sorry for alligators, sorry for pandas. Bye. Whoa, you lost the point. Bye. Okay, come on, koalas. Yes, you're doing. You can do it, koalas. Sea dragons. Come on. Who's the winner? The winner is. Oh, congratulations, Alvis. Congratulations. You are the winner of this game. Okay, very good. Okay, remember the quadrant with positive and negative. Remember, always X and later Y. Okay, quadrant 3. Okay, perpendicular slopes, parallel lines. We have, remember, parallels and lines. Okay, let's remember some very important aspects. Remember that when we are speaking about one intersection, one solution, okay? Parallel lines, no intersections with no solutions. And when the line contains infinitely many solutions, okay? Very good. This game was very interesting. Okay, remember that we are speaking about how we can graph the lines expressions that we can graph using the graph method, okay, and find the intercept. But it's necessary that we have to understand how can we use the method, okay, in this case the substitution method. Later we're going to learn about mode methods. In this case, remember, we are using the substitution method. For no more, remember, you are in my heart, you are in my mind, you are always here for me. Okay? Remember, you are the number one. So, no more. Let's see the next Monday to the next class. Okay? Bye.